Good morning all. So today we will discuss some various kinds of lifting machine. So this is another lifting machine which name is double purchase grab winch. In the last class we discussed about the simple wheel and axle case, the single purchase grab winch and the worm and worm wheel case. So today we will discuss about the double purchase grab winch case. So this is the figure of double purchase grab winch, which is a advanced version of single purchase grab winch. So in this case there are 4 numbers of teeth are there, as you can see in this part. As we know that in case of single purchase grab winch there are 2 numbers of teeth are there, but in case of double purchase grab winch there are 4 numbers of teeth: T1, T2, T3 and T4. So now T1 and T3 are the number of teeth for the spur wheels, T2 and T4 are the number of teeth for the pinions, and L be the length of the handle, R be the radius of the load drum, W be the load lifted, and P be the effort load to lift the load. Now we know that in case of any lifting machine the value of velocity ratio will be different, but the mechanical advantage will be same. So in case of double purchase grab winch, the value of velocity ratio is equal to L by R into T1 by T2 into T3 by T4. And for the mechanical advantage, the formula will be W by P. Hence the efficiency of the machine is equal to MA by R. So here the efficiency is equal to mechanical advantage by VR. So now there is a numerical based on double purchase grab winch. So here in a double purchase grab winch the teeth of pinions are given as 20 and 25, that of spur wheels are 50 and 60. So here all the teeth value are given for pinion and the spur wheel. Then length of the handle is given as 0.5 meter and radius of the load drum is given as 0.25 meter. So here if the efficiency of the machine is 60%, find out the effort required to the lift a load of 720 Newton. So in this case we have to find out the effort of the double purchase grab winch. So as per the question, first of all we need to write down all the data given. So number of teeth, that is T2 value is 20, T4 value is 25, T1 value is 50, T3 value is 60. The length of the handle, that is L value is given as 0.5 meter, radius of the load drum, that is R value is given as 0.25, efficiency is given as 60%, that is 0.6. The load lifted is given as 720 Newton. Now, according to the formula, we know that velocity ratio for the double purchase grab winch is equal to L by R into T1 by T2 into T3 by T4. So here all the values are given in the question. So that's why we need to put all the values. Hence, the velocity ratio of the double purchase grab winch is equal to 12. Now, we can find out the mechanical advantage, but in this case, the value of P is not given, but W is given. So that's why W by P, that is equal to 720 by P. After that, we can find out the efficiency, and we know that the efficiency is equal to MA by VR. So as per this question, the MA value is found to be 720 by P and the velocity ratio is found out as 12. that is equal to 60 by P, and by cross multiplication we can find out the value of P, that is the effort required in Newton to lift the load, so which is equal to 100 Newton. So this is the value of effort required to lift a load of 720 Newton. Now the last machine of lifting, which is simple screw jack. So you can see this is the figure of simple screw jack, which is consist of a screw fitted in a nut which form the body of a jack. The principle on which the screw jack is worked is similar to the inclined plane. Now the velocity ratio of the simple screw jack is equal to 2 pi L by P, where L be the length of the effort arc, P be the pitch of the screw, and W be the load lifted, and P be the effort applied to lift the load at the end of the tail lever. Now the mechanical advantage is equal to W by P, and efficiency as usual mechanical advantage by velocity ratio. Now there is a numerical based on simple screw jack. So the question is, a screw jack has threaded of 10 mm pitch. What effort applied at the end of a handle 400 mm long will be required to lift a load of 2 kN if the efficiency at this load is 45%. So according to the question, the data given are pitch of the thread, that is P value is given as 10 mm, length of the handle, that is L value is given as 400 mm, the load lifted, that is the value of W is given as 2 kN. So we have to convert the kilonewton into Newton, so that's why the 2 kN is equal to 2000 Newton, and the efficiency is equal to 45%, which is equal to 45 by 100 is equal to 0.45. Let the P is equal to effort required to lift the load. So first of all we need to find out the velocity ratio for the simple screw jack. So that's why the velocity ratio formula is equal to 2 pi L by P. Hence the L and P value is given in the question. The L is 400 and P is 10. So by putting this value, we have the velocity ratio is equal to 251.3. Then the mechanical advantage formula is equal to W by P. So in this case, P value is not given, so that we can write W by P, that is equal to 2000 by P. And in this case, efficiency is given, so that's why we can find out the value of P from the relationship of efficiency, mechanical advantage and velocity ratio. Hence we know that efficiency is equal to mechanical advantage by velocity ratio, that is 0.45 is equal to MA by VR. That is equal to MA is 2000 by P divided by VR equal to 251.3. Hence by cross multiplication we can find out the value of P as 17.7 Newton. So this is all about the chapter 5, which is simple machine. So we will start the chapter 6 in the next class. So today this much. Thank you.